All right, so you ready to jump into some business analytics today? You've been taking a course, right?
Yeah, seems like you're deep in the data trenches with Chapter 2, Obtain the Data, an introduction to business data sources, and even some lab assignments.
You got it. This deep dive, we're going to become fluent in all things data, databases, data types, and how to prep data for analysis, the whole shebang.
Well, first things first, the SOAR model. Specify a question, obtain the data, analyze the data, and report the results. Your course material seems to emphasize that.
SOAR, I like it. Simple, but effective. So let's say you've got your question locked in. Where do you even start looking for the data?
Well, you got to start somewhere, right? How about within the organization itself? Internal data?
Internal data, that makes sense. It's all the info a company already has.
Exactly. And those enterprise resource planning systems, those big ones like SAP or Oracle, they're like data Fort Knox.
Wow, data Fort Knox. So what kind of stuff are we talking about here?
You name it, they got it. Sales records, inventory, customer details, financial transactions, all that good stuff, structured and stored in a central database.
Okay, so if I'm trying to figure out why, let's say, sales took a nosedive last quarter, I could use these internal data sources to find out why.
You got it. But here's the kicker. You're not limited to just internal data. External sources could be a gold mine too.
Ooh, external sources. Like what? Give me some examples.
Think social media. Think census data. Publicly available financial statements from competitors. It's a whole other world of data out there.
Okay, that's a lot of data. It can get pretty overwhelming. How do you even know where to start?
That's where big data comes in. Got to remember the 4 V's. Volume, variety, velocity, and veracity.
4 V's. Okay, break it down for me.
All right, so imagine you're a marketing manager for, let's say, a clothing company, trying to figure out what customers want. The sheer amount of data from online purchases, website visits, and social media is huge, right? That's volume.
Okay, that makes sense. So variety would be the different types of data, right? Like website clicks versus customer reviews.
Bingo. Then you've got velocity, the speed at which that data is coming in. New posts, reviews, orders, it never stops.
And I'm guessing veracity is all about making sure that data is accurate and trustworthy, especially if you're using stuff like social media where, let's be honest, anyone can say anything.
You nailed it. Those 4 V's are key for any big data project.
All right, so we've got our internal and external data sources. How do we keep it all organized? Databases, right?
Databases, the unsung heroes of data management. They're the structured containers for all that precious information.
So instead of data chaos, we have a nice organized database.
You got it. And to manage that data, you need a database management system, or DBMS. It's the software that lets you work with the database.
Okay, so if the database is the library, the DBMS is like the librarian helping you find the right book.
Perfect analogy. Think MySQL or Oracle database, big players in the database world.
Now, I see in your course material they talk about different types of databases. It's not a one-size-fits-all situation, huh?
Not at all. Each type has its own strengths. Relational databases, they're like spreadsheets on steroids. Great for structured data, super common in business.
Right. And you mentioned object-oriented databases and distributed databases. When would you use those?
Okay, think of Facebook, right? They deal with tons of complex data. Users, posts, images, comments, all connected. Object-oriented databases are perfect for managing that kind of complexity.
So they're built to handle more intricate relationships between all the different pieces of information.
Exactly. Now imagine Amazon, a global giant. They have data spread out across servers worldwide. Distributed databases allow them to manage all that data efficiently, ensuring quick access. Pretty cool stuff.
Okay, I'm starting to see how each type has its specific purpose.
And then there are data warehouses, massive data repositories for analysis and reporting. Think of a big retail chain analyzing sales across hundreds of stores. A data warehouse lets them combine and query all that data efficiently.
Got it. Let's circle back to relational databases for a sec. Your course material keeps talking about tables, fields, and records. What are those exactly?
Picture a super organized digital filing cabinet. Each drawer is a table. You might have a customer's table and a products table.
So the tables are like categories or subject areas in the database.
Exactly. Now, within each table, you have columns, which are called fields. These fields hold specific information about the subject.
So for our customers table, the fields could be things like customer ID, name, address, email, right?
Spot on. Each field captures a specific detail about the customer, and each row in the table represents a unique instance of that subject. That's a record.
So one row in the customers table would be all the info for one specific customer.
Exactly. Tables, fields, and records, those are the building blocks of a relational database.
It's like a giant organized spreadsheet. Each row tells a complete story.
That's a good way to visualize it, but databases go way beyond spreadsheets. They can handle massive amounts of information and allow for super complex queries and analysis.
Okay, we've got all these tables with their fields and records, but how do they all connect? It can't just be a bunch of separate tables, right?
That's where relationships come in. They're the threads that tie the database together. You've got one-to-one, one-to-many, and the tricky many-to-many.
Relationships that look sense. It's all about connecting the dots. Give me an example of how these relationships work in the real world.
Sure. Let's say you're a bank looking at customer transactions. A one-to-one relationship could be a customer and their unique account number. One customer, one account number. Nice and straightforward.
Gotcha. So what about one-to-many?
Let's stick with our bank example. One customer might have a checking account, a savings account, and a money market account, right? That's one-to-many.
Okay, so one customer can have multiple accounts, but each account is still tied to that one specific customer.
Exactly. Now for the fun one, many-to-many. Think students and courses at a university. One student can take many courses, and each course has many students.
Ooh, okay, that one sounds a bit trickier. How do you manage all those connections in a database?
Usually you'd use a linking table. It acts as a bridge, connecting students to courses and keeping everything nice and organized.
So instead of a jumbled mess of connections, you create a separate table to keep things clear.
Exactly. Relationships are super important for unlocking the power of a relational database.
Right, we've explored databases, but how do we actually get that data out and ready for analysis? Data formats and file types, right?
You got it. One of the most common ways data is delivered is through comma-separated files, .csv files. They're like the universal data transporter.
Ah, good old .csv files. They seem pretty simple, but they can hold a lot of data, right?
Oh yeah, they're data minges. Efficient, versatile, plain text, but easily opened in spreadsheets or programming languages for analysis.
And they can handle way more information than your typical Excel spreadsheet, right?
Absolutely. Perfect for those large data sets, which are more and more common these days.
Now, your course material also talks about the level of aggregation. What does that mean exactly?
Think of it like choosing the right lens for your data investigation. Do you want to see every single transaction? That's raw data.
It's like looking at the data under a microscope.
Exactly. But sometimes you need a wider view. Aggregated data gives you summaries like subtotals and averages.
So it's like stepping back and seeing the big picture trends instead of individual data points.
Precisely. Choosing the right level of aggregation all depends on what you're analyzing and the questions you're asking.
All right, we've got our data, it's in a database, and we've picked our level of detail. What's next?
Now we get to the core of data analysis, figuring out the different types of data. Not all data is created equal. We can broadly categorize it as either categorical or numerical.
Okay, I'm following along. Categorical data is like grouping things, right? Like categorizing customers by age or location.
Exactly. It's about assigning labels or attributes. And within categorical data, you've got nominal and ordinal.
Hold on, refresh my memory. What's the difference between those two again?
Okay, think about eye color. Blue, brown, green. Those are nominal categories. No ranking or order.
Okay, got it. So ordinal data would be categorical data, but with a ranking or order.
You got it. Think about education levels. High school, undergraduate, graduate, clear progression there.
All right, that makes sense. So what about numerical data then?
Numerical data is all about numbers. Sales figures, temperatures, exam scores, the stuff you can do math with. We can even break this down further into interval and ratio data.
Hold on, this is where I always get a little lost. What's the key difference between interval and ratio?
All right, think about temperature scales. Celsius and Fahrenheit, those are interval data. Consistent interval between each degree. But 0 degrees doesn't mean there's no temperature, right?
Ah, okay, so it's like a ruler where 0 is just a starting point, not the absence of the thing you're measuring.
Exactly. Now think about height or weight. Those are ratio data. 0 height or 0 weight means there's nothing there.
So ratio data has a true 0 point, representing a total absence of whatever you're measuring.
You nailed it. Understanding the difference is important for picking the right statistical analysis later on.
Okay, this is starting to make a lot more sense. We've covered different data sources, database types, data formats, and even the different types of data. Feels like we're finally ready to start the analysis.
We are. But before we jump into the exciting world of data analysis, there's one crucial step. Data preparation.
Data preparation. Sounds kind of boring, but I guess it's important.
Oh, it's super important. It's all about data quality, cleaning things up, and dealing with missing values. Think of it as spring cleaning for your data.
So basically, making sure our data is accurate, complete, and consistent before we jump to any conclusions.
Exactly. Data preparation is the foundation for reliable analysis. It's all about transforming raw data into a pristine data set that's ready to be explored.
Okay, I'm sold. Let's get into the details of data prep. What are we actually doing here? Just fixing typos and stuff.
It can involve that, yeah, but it goes deeper. You might need to trim white space from text fields, get rid of weird characters that can mess up your analysis, or standardize data formats to make sure everything is consistent.
I can see how those little details could really throw things off.
Absolutely, inconsistent data formats can cause major headaches when you're trying to combine data from different sources.
I bet software can be a lifesaver here. Are there specific tools for data preparation?
You bet. There are tons of powerful tools out there to help you whip your data into shape.
Okay, I'm intrigued. Spill the beans. What are these data wrangling superheroes?
Well, let's save that for the next part of our deep dive. Get ready to meet the software superstars that'll help you transform your data into a masterpiece, ready for analysis.
Okay, so last time we were talking about those software tools that can help us with data preparation. It's like having a whole team of data assistants, right?
Exactly. Think of them as your data pick crew, getting anything ready for the big race, which is the analysis.
I like that. A data pick crew. All right, introduce me to this crew. Who are the key players?
Well, first up, we have a familiar face, good old Microsoft Excel.
Oh yeah, Excel. I've definitely spent a lot of time with Excel. It's a classic for a reason, right?
It really is super versatile. From basic calculations to making charts and graphs, Excel can handle a lot of data prep tasks.
It's great for getting a feel for your data, but when you're dealing with the massive data sets, I can imagine it starts to struggle a bit.
You're right, that's where we bring in the big guns Power Query.
Power Query, tell me more.
It's like Excel's super-powered sibling. Power Query lets you connect to all sorts of data sources, clean and transform the data, and even reshape it to fit your needs.
So it can do things like removing duplicates, merging data from different sources, even pivoting data.
Exactly. It's a game changer. And if you want a more visual approach, there's Tableau Prep.
Tableau, I've heard of that one. Isn't that more for visualizations?
Tableau is known for its visualizations, but Tableau Prep is specifically for data preparation.
So it's like a visual data playground. You can actually see the data being transformed, cleaned, reshaped right in front of you.
You got it. Makes it so much easier to understand and refine your data cleaning steps. And if you're dealing with truly massive data sets, then there's Alteryx.
Alteryx, that one sounds familiar. Is that for enterprise level stuff?
Yeah, Alteryx is like the industrial strength data preparation machine. It can handle complex data blending, advanced data cleansing, and even automate those repetitive tasks.
So if you're a data scientist swimming in terabytes of data, Alteryx is your best friend.
Pretty much. It's like having a whole team of data engineers working for you. But let's not forget about the analytical tools, the ones that help us actually extract insights from all this beautifully prepared data.
Right, we've prepped the data, now it's time to get those insights. Where do we start?
Well, when it comes to data visualization, Tableau and Power BI are the rock stars.
Tableau, I was hoping you'd mention that one. I've seen some seriously impressive dashboards and visualizations created with Tableau. What makes it so great?
Tableau is known for its ease of use, that drag and drop interface, and it can create some really stunning interactive visualizations. You can explore data, identify trends, and present your findings in a way that's visually engaging.
And what about Power BI? How does it stack up against Tableau?
Power BI is another really powerful visualization tool, and it integrates seamlessly with all the Microsoft stuff. So if you're a Microsoft shop, Power BI might be a good fit.
It's like having a visualization tool that speaks the same language as all your other business applications.
Exactly. But before we dive into the world of charts and dashboards, we need to talk about the tools that help us with the statistical heavy lifting.
You mean the tools that help us test hypotheses, run regressions, that sort of thing?
Exactly. For that, there's Gradle.
Gradle, I haven't heard of that one.
Gradle's a free, open-source statistical software package. It's surprisingly powerful. Great for econometrics, but it can handle a wide range of statistical analysis tasks.
So it's a good option for those who need to crunch some serious numbers without breaking the bank.
Exactly. And of course, there's the dynamic duo of data science, R and Python.
Ah, yes, R and Python, they seem to be everywhere these days. What makes them so popular for data analysis?
R and Python are incredibly versatile. They can handle everything from cleaning and manipulating data to statistical modeling and even machine learning.
Sounds like they're the ultimate data multitaskers.
They are. Plus, they have these massive libraries of packages and functions that add even more functionality.
So you don't have to code everything from scratch. You can just grab a pre-built tool or function for specific types of analysis.
Exactly. It's like having a toolbox full of specialized data gadgets ready to tackle any challenge.
This is all super interesting, but I have to admit I'm feeling a little overwhelmed. There are so many tools and techniques to learn. How do you even know which ones to use?
That's a great question. It really depends on what you're trying to do, the size of your data, your budget, your technical skills, all sorts of things.
So it's not about finding the best tool, but finding the right tool for the job.
Exactly. And sometimes you might even use a combination of tools, playing to the strengths of each one.
Like a data dream team.
You got it. It's all about finding the right mix of tools and techniques to unlock the insights in your data.
This deep dive has really opened my eyes to the world of business analytics, data sources, databases, data types, preparation, and now all these amazing software tools. It's a whole data universe out there.
It is. And the best part is it's always evolving. New tools and techniques are popping up all the time.
It's a never-ending data adventure. But beyond all the technical stuff, I think there's a really important human element too, right?
Absolutely. It's not just about the numbers and the tools. It's about asking the right questions, thinking critically, and using data to tell a story that can help people make decisions and take action.
So it's a blend of technical skills, critical thinking, and storytelling.
You got it. That's what makes data analysis both a science and an art.
It's amazing how much we've covered in this deep dive. We started with data sources and databases.
Yeah, all those different types of data, how to prep the data, and then all the software tools.
It's like we went through data boot camp.
And you came out a data pro, ready to tackle any analysis.
I do feel a lot more confident about business analytics now.
That's great to hear, but it's really just the start of your data journey, you know?
Yeah, it does feel like we've only just scratched the surface.
There's always something new to learn in data. It's constantly changing with the new tools and techniques all the time.
That's what I love about it. It's like a never-ending adventure.
Exactly. And the best part, these skills aren't just for business.
Oh, I thought business analytics was all about, well, business.
Of course, it's a core application, but you can use data analysis in almost any part of your life.
You know, now that you mention it, I can see that. Analyzing my personal spending habits, tracking my workouts, even looking at trends in my hobbies.
Exactly. Like you could track your monthly expenses, see where your money's going, or you could track your workouts and sleep to improve your fitness routine.
Like having a personal data antist 24/7?
Exactly. And it's not just about personal insights either. You can use these skills to better understand the world around you. Look at climate change data, analyze social media trends, even investigate patterns in your favorite sports team's performance.
It's pretty cool to know I have the tools to understand and interpret data for my career, my personal life, or just because I'm curious.
That's the power of data analysis. It's a language that can unlock insights in any area.
This deep dive has been great, not just for understanding business analytics, but also for seeing how I can use data analysis in all parts of my life.
And remember, it's not just about the technical stuff. It's about asking the right questions, being critical, and using data to tell a story that can help people make decisions and take action.
So it's all about technical skills, critical thinking, and storytelling working together.
Exactly. And that's what helps you truly unlock the power of data.
I'm definitely leaving this deep dive feeling inspired and ready to use what I've learned. Thanks for taking me on this data adventure.
You're very welcome. Just remember, the world of data is huge and always changing. So keep exploring, keep learning, and never stop asking questions.
Great advice. And on that note, we'll wrap up this deep dive. Until next time, happy analyzing.